So welcome back to STEM Baba. In the last video we discussed about a sine curve and its variation. Now in this video we'll discuss about cosine curve and its variation. Then we'll see that how these curves plays an important role in our day-to-day life, that how these curves can be used to model the breathing cycle, how this curve can be used to model the tidal cycle, and so on. So do watch the video till the end. For now, take a deep breath and relax. Okay, so the graph of y equals to cosine x. Now this is the second part. If you haven't watched the first part of the video, you can go to the description, the link will be there. You can watch the first part and then come to this part. This is the second part. Okay, in the first part we discussed about the graph of sine x and variations. So that video is very important for having the basic idea, and then you can come to this video after watching that. Link is given in the description below. Okay, now we all know that the period for cosine x is 2 pi. So after this interval, the values for cosine x will going to repeat. So we're going to plot the graph between these 2 points, and afterwards we just have to repeat the graph to get the graph of cosine x. Okay, so first x, I'll be taking that x to be 0 radians, then pi by 6 radian, then pi by 3 radian. I'm taking values at an interval of pi by 6, then pi by 2 radian, right? Now cosine 0 is what? 1. Cosine pi over 6 is square root 3 over 2. Cosine pi by 3 is 1 over 2, and cosine pi by 2 is 0, right? What you can see from observe from here, that x, as x increases from 0 to pi by 2, y decreases from 1 to 0, right? Now let's move forward. Now we can take angle to be 2 pi by 3, right? Then 5 pi by 6, then pi. Now if cosine 2 pi by 3 is what? Minus 1 over 2. This is minus square root 3 over 2, and this is minus 1. Now here we see that as x increases from pi by 2 to pi, the value of y, it decreases from 0 to minus 1, right? Now further, I can take angle to be 7 pi by 6, then 4 pi by 3, then 3 pi by 2. Now the y value corresponding to these would be minus square root 3 over 2, minus 1 over 2, and then 0. Now what we can observe from here, that as x increases from pi to 3 pi by 2, the y value also increases from minus 1 to 0. Now finally we can take angles to be 5 pi by 3, then 11 pi by 6, and finally this is 2 pi. Now this would be 1 over 2 square root 3 over 2 and 1. Now what we can observe from here, that as x increases from 3 pi by 2 to 2 pi, the y value also increases from 0 to 1, right? Now we have the corresponding points. We can plot these points on the Cartesian coordinate to get the graph of y equals to cosine x. So This is the y-axis I can take. This would be the x-axis I can take, right? Now this is 0 here. Here we have pi by 2, then pi, then 3 pi by 2, and 2 pi. These are the 5 key points. Now when x is 0, y is 1. So here I can take 1. Here I can take -1. So this is the first key point. Then at pi by 2 we have 0. At pi by 2 we have 0. So 0. At pi we have -1, -1. 3 pi by 2 again 0. 2 pi we have 1. You can join these points with a smooth curve like this. Now this is the cosine curve between this interval 0 to 2 pi, and afterward it will going to repeat. It will repeat like this. It will go in the right side like this and in the left side like this, right? So this is the perfect graph. If you sketch on the desmos.com, you'll obtain the graph like this. This is for y equals to cosine x. Now few things we can observe from here. We can see that the range is between -1 to 1, right? I can write the range for cosine x is -1 to 1. Now the domain, now x value can vary from -infinite to infinite. So the domain would be -infinite to infinite, right? Also we can say that the cosine function is an even function because it is symmetric about the y-axis. I can write that cosine -x will be equals to cosine x. This thing we discussed earlier also, that cosine function is an even function and sine function is an odd function. One more thing we can observe from here. Now here if you look this graph carefully, we observe that the graph y equals to cosine x is the graph of sine x with the phase shift of pi by 2. Here you can see the phase is shifted to pi by 2 here. If you observe at this point here, if you see this curve, this red one curve, this and up to this is exactly this graph is similar to sine curve, but there is a phase shift of pi by 2. So what we can write here, that cosine x, it is equals to sine x plus pi by 2. This thing we can write, right? Now because of this similarity, the cosine curve and the sine curve are known as sinusoidal graph. What we call them? Sinusoidal graph. Because of this similarity, because there is only a phase shift of pi by 2. So these graphs are known as sinusoidal graph. Now we're going to discuss the variation of cosine x. So the variation of y equals to cosine x. First variation, it can be y equals to a cosine x, right? What is a here? It is similar to what we discussed for sine x. Here a would be the amplitude. Amplitude is a here, and we just take the positive value, so I'm taking mod a, right? Oh sorry, this is a sine bx. This should be the good variation. And what would be the period? Period would be 2 pi by p. You may ask why. If you have seen my previous video, then you will be having no confusion, but still I'm giving an explanation here, because we know that for y equals to cosine x, the period is 2 pi, right? The x is between 0 to 2 pi. Now here this is cosine bx, so here bx, it should be between 0 to 2 pi. Divide with b both the side, so 0 greater than or equals to b is less than or equals to 2 pi by b. So here we can see that the period would be 2 pi by b. That is how I can write this, the period. Now let's take an example. So this is the example here. Here we need to determine the amplitude and the period for y equals to minus 3 cosine pi by 2x. Okay, and then also we have to graph between x minus 4 to 4. Okay, so first of all, amplitude, if you compare the given function with y equals to a cosine bx, I can write that the amplitude a is 3 here. I'm just taking the magnitude. Now then the period, so period would be 2 pi by b, and here b is pi by 2, so that would be 4. So period is 4. Now I'm assuming that you have seen the previous video, so you can easily graph this without any confusion. First we have to write the 5 key points as we did in the previous video. So the first point, x1, I'm taking to be 0. Now why I'm starting from 0? Because we know that between 0 to 4, after 0 to 4, the curve will going to repeat itself in the left, in the right, both side. So x1 is 0 here. Now x2 would be, do one thing, period is 4, so divide with 4, that would be 1. So add this 1 to this, 0 plus 1 is 1. x2 would be, this is the second key point, x3 would be 2, x4 4 would be 3, and x5 would be 4, right? So these are the 5 key points. Now corresponding to this point, find the value of y1, y2, y3, y4 and y5. So when you put x as 0 here, cosine 0 is 1, you will get minus 3, right? Then you will get 0, then you will get plus 3, because cosine, when you put cosine x as 2 here, this would become cosine pi, and cosine pi is minus 1. So minus 1 times minus 3 is 3, then 0, and then again minus 3. So these are the values. You can plot this on the graph paper. So here I'm plotting it. This is the x-axis. Here I can take that this is 1, 2, 3, 4. This would be the period 0 to 4. And these are the 5 critical points, not the critical points, key points. Now in the y-axis we have to go up to 3, because amplitude is 3 here. So 3 in the positive y and minus 3 in the negative y. This is minus 3, plus 3 I can take, and this is minus 3, right? Now let's plot the points. 0, minus 3. So when x is 0, y is minus 3. So this is the first point, right? And this point, then this point, then this, and finally this. So join all these points with a smooth curve like this. Now our aim was to sketch between minus 4 to 4. So we have sketched between 0 to 4. So I can do it like this. I can extend the curve in the negative x direction, right? Minus 1, minus 2, minus 3, and then minus 4. This is minus 4 here. Just repeat the curve. It will go like this, and here it will reach the maximum point, and then here, then here. So this would be like this. So this is the graph for y equals to minus 3 cosine pi by 2x between minus 4 to 4. So this is the required graph. Now let's see one more variation for cosine x. Now another variation we have y equals to a cosine bx minus c. Here b is greater than 0. Now this is similar to the variation that we discussed for sine curve, right? and there we discussed that the amplitude would be mod A, this would be the amplitude, and the period would be 2 pi by B, right? Now what is this minus C, what this is denoting here? Now here there is a phase shift of C by B. Now here you can see in the graph, this X starts from here. X starts from, earlier we discussed that X ranges from 0 to 2 pi, right? Earlier we saw this, but now since there is a phase shift, so now X will start from C by B and then it will end at 2 pi by B plus C by B. If you see the period would be 2 pi by B, right? So this was one more variation similar to the one that we discussed for the sine curve. Now let's take an example to understand it better. Now this is the question. Now here amplitude would be half, right? This would be the amplitude. Now also the period would be 2 pi by B. So 2 pi by B here is 4. So that would be pi by 2. So period would be pi by 2. So after this pi by 2, the things will going to repeat. Now also that here we can see here this is pi here. That is the value of C would be minus pi, right? You may ask that how C is minus pi. If you recall the standard equation, y equals to 1 over 2 cosine bx minus c, right? This was the standard one, and here the phase shift would be C by B. Here C is what? Minus pi here, that is why C is minus pi. So phase shift would be C by B, which would be equals to C is minus pi. B here is 4, so minus pi by 4. Therefore the graph will start from minus pi by 2 and then it will end at the period is pi by 2, so pi by 2 plus minus pi by 4, so that would be equals to pi by 4. Therefore x would be from minus pi by 4 to pi by 4. Okay, now 5 key points we have to write. First key point is just the starting point, x1. Here x1 is minus pi by 4. Now how to find other 4 key points? What the procedure was, divide the period with 4. So pi by 2 divided by 4 is pi by 8. Now start adding this number to this x1. So if I add pi by 8 to it, what you will get? A minus pi by 8. Then x3, this would be 0, x4 would be pi by 8, and x5 would be pi by 4. These are the key points. Corresponding to these key points, find the value of y, y1, y2, y3, y4 and y5. So y1 would be 1 over 2, y2 would be 0, y3 would be minus 1 over 2, y4 is again 0, and y5 is 1 over 2. So these are the points. Now we can plot the graph easily. So this is the y-axis, this is the x-axis, right? Here I can take plus half, minus half. Here this is 0, minus pi by 8, and this is minus pi by 4. This is pi by 8 and pi by 4. Now plot the key points. When x is 0, y is, sorry, when x, we'll start from x1. So when x1 is minus pi by 4, y1 is half. So this would be the point, then this would be the point, then this would be the point, then this one, and finally this one. So join these points with a smooth curve like this. So this is the curve for y equals to half cosine 4x plus pi. And the curve will going to repeat in the right and the left side simultaneously, right? So this would be the curve. Now let's move forward. Now the vertical shift of sinusoidal graph. So till now we discussed this type of graph, y equals to a sine bx minus c. This we discussed in the previous video, and in this video we discussed y equals to a cosine bx minus c. Now here the graph can also shift vertically. If I add d here plus t, here also plus t. Now this constant d causes a vertical shift in each of the graph, and if d is positive, if d is greater than 0, positive, then the graph is shifted upwards. Then the graph is shifted upwards, and if d is negative, less than 0, then the graph is shifted downwards. Now earlier the graph was oscillating about the x-axis, but for this kind of functions the graph will going to oscillate about the horizontal line y equals to d. Right? Now what would be the maximum value for y? The maximum value for y, this would be d plus mod a, and the minimum value would be d minus mod a. This is the overview. Now let's take an example to understand it better. Now here we have an example. We have to graph one period of the function y equals to half cosine x minus 1. Okay, clearly we can see that the value of d is minus 1 here. That means the graph will going to oscillate about y equals to minus 1. Right. Next, what would be the amplitude? Amplitude would be 1 over 2. Period, it's simple. Period would be 2 pi. There is no phase shift here, and period is simply 2 pi. Now the 5 key points, x1 will start with 0, then x2 would be, so divide the period by 4, so that would be pi by 2. So start adding pi by 2 here, so pi by 2, then x3 would be pi, x4 would be 3 pi by 2, and x5 would be 2 pi. Right. Now here y1 would be now when x is 0, cosine 0 is 1, so half minus 1 is minus half. So we'll start from this. X is 0, then y should be minus half. Then y2, this would be minus 1, then y3 would be minus 3 over 2, y4 would be minus 1, and y5 would be minus 1 over 2. Now sketch the graph by using these points. So this is the y-axis I can take, this is the x-axis, right? I can extend it a little bit more, and right, so this is the y-axis, this is the x-axis. Now this is x is 0 here, then here this is pi by 2, here we have pi, then 3 pi by 2, and finally 2 pi. Here we have minus 1 over 2, minus 1, and further this would be extend a little bit more, this is minus 3 over 2. And the points we have, when x is 0, y is minus 1 over 2. When x is pi by 2, y is minus 1. Then when pi, we have minus 3 by 2, then minus 1, and then again to 1 by 2. So here we have 1 by 2. You can join these points with a smooth curve like this. Now you can see this graph is oscillating about y equals to minus 1. This is y equals to minus 1. This graph is oscillating about this line, and this would be the amplitude, which is half here. You can see it from here also. This is the amplitude 1 over 2. Right. So this would be the graph for y equals to half cosine x minus 1. So these are the all possible variation for sinusoidal graph. No other variation are possible. Now let's try to understand that how this graph play crucial role in our day-to-day life. So let's move forward. Now let's try to understand that how this graph plays an important role in our day-to-day life. Now, our breathing cycle consists of alternative period of inhaling and exhaling. Now here this x-axis shows the time in seconds and the y-axis shows the velocity of airflow in the human body, and this would be in liter per second. This would be the unit, right? Now here you are inhaling from this point to this point, and then from this point to this point you are exhaling, and the breathing cycle can be modeled by using the sine function, which is y equals to a sine bx. And this graph basically shows the normal breathing cycle. Now can you model by using this graph, can you model the breathing cycle using a sinusoidal graph? Of course we can. Now here we can see that the period is 5 here. This would be the period. This is the period, right? And this period is 5, right? It starts from 0, ends at 5, so this would be the period. Now what would be the amplitude? This would be the amplitude. Amplitude here is 0.6. So A, we have 0.6, and period is what? 2 pi by B. This is the period, and this is given to be 5 from the graph, and from here B would be equals to 5 by 2 pi. Sorry, I did a mistake. This is 2 pi by 5. So B, we have 2 pi by 5. We have the value of A, we have the value of B. We can plug it here. So Y would be equals to A is 0.6 sine 2 pi by 5 x. So this would be the function that would define your breathing cycle. This is a breathing cycle for normal person. So this is why I was saying in the initial of the first video that these graphs are very important, sinusoidal graph. One more practical example I'm going to take for the tidal cycle. Let's see that. Now in this example we are given with this figure. Here you can see that the depth of water at a boat dock varies with tides. Now the depth is 5 feet. Here you can see the depth is 5 feet at the low tide and 13 feet at the high tide, right? Now on a certain day, low tide occurs at 4 a.m. Here you can see this is 4 a.m. Now here x is the number of hour after midnight. So here we have 0, then 4, 10, 16 and so on. Now the y-axis shows the depth of water. Now the high tide occurs at 10 a.m. You can see here at 10 a.m. the high tide occurs. Now our task is to use the sine function, which is y equals to a sine bx minus c plus t, to model the water's depth. Okay. Now here if you see carefully, this graph is oscillating about this line y equals to 9. About this line this graph is oscillating. So there is a vertical shift, right? This is the vertical shift, and this shift is d equals to 9, right? So the value of d is 9. Now what is the amplitude here? Amplitude would be 4. 13 minus 9 is 4. This would be the amplitude. Now what is period here? Now clearly we see that this, if you see this blue curve, this blue section, it starts from here and it ends at here. Rest is the repetition of this blue curve. So this would be the period, right? Here x is 7. It is just at the middle of 4 and 10, so 7. Here this would be 19. So the period would be 19 minus 7 is 12. That would be the period. Now so what I can say here, that a period is what? 2 pi by b. This was the formula. So this is equals to 12. So from here b would be equals to 2 pi by 12, and that is pi by 6. So this is the period. Now what would be the value of c? Now we know that C by B, this is what the shift, the phase shift, which we can see from the graph. Here the phase shift is, this is 7. So phase C by B is the phase shift, which is 7 here. And B we already calculated to be pi by 6. So C would be 7 times B. B is pi by 6. Now we have all the values A, B, C, D. We can plug it here to give the answer. So y equals to A is 4 sine, B is pi by 6, x minus C is 7 pi by 6, plus D here is 9. So this is the required form, and by using this this equation we can tell that at what time what would be the depth. Suppose you need to tell that what is the depth at x equals to 2 am, right? Let's plug x as 2 here to find y. So this is the significance, or this is the utilization of these curves, sinusoidal curves, in our day-to-day life. So with this we have discussed all the important things. Now we're going to meet in the next video. Till then, take care of yourself. Goodbye.